Hello students, welcome to askIITians.com. My name is Nishant Vora and I am a graduate of IIT Patna. I have been associated with Ask IITians since last 2 years. So the topic that we are going to study today is continuity and differentiability. Now I have divided this topic into several parts like continuity of a function, the basic definition, then various theorems on continuity, and then I will tell you about the definition of derivability and certain theorems which are related to derivability also, so that the learning is efficient, right? Now let us start with the first part, that is continuity of a function. Now under this topic I am going to tell you about when a function is continuous at a point, and also we are going to talk about when a function is continuous in an interval. So let's start with the first part. So students, let me quickly discuss the topics that we are going to cover in this chapter, continuity and differentiability. So the topics that we are going to cover in this chapter are, first of all, I will tell you about the continuity of the functions, right? When the functions are continuous, what is the mathematical definition of continuity, and then I will tell you about the reasons and the types of discontinuities, right? There are several types of discontinuities, I will talk about them. Then I will tell you a few theorems which are related to continuity. Okay, after that I will tell you about continuity of composite functions. What are composite functions? Composite functions are those functions basically if there are two functions, right, and the input of one function becomes the output of another functions, right, or the output of one function becomes the input of other functions, then such type of functions are called composite functions. So we will talk about the continuity of composite functions also, and after that I will go to the next part, which is derivability, or which is also called as differentiability, right? So what is derivability, what is the definition of it, right, how to determine whether a function is differentiable or not. So I will talk about this in this section, which is differentiability, and then I will also again talk about the theorems which are related to differentiability, okay, that we will see under this section. And after that I will tell you how to check about the differentiability by using differentiation, standard differentiation that we all know, right? And at last we are going to solve some IIT-JEE problems which appeared in the past year papers. Okay, so this will help you boost your confidence and gain more problem solving skills, right? So let us go through all these topics one by one. Okay students, so let me begin by giving you a general introduction on the continuity of the function. So first I will tell you what is the continuity of the function, how to check whether a function is continuous or not, and then I am going to tell you about the mathematical definition of continuity, mathematically how to check whether a function is continuous or not. And after that we are going to talk about continuity in an interval, right? So whether the function is continuous in an interval a to b or not. So that we will study under this section. All these are the topics that we are going to cover. So let's start with the first part, which is general introduction, right? So first of all, to study this chapter, okay, it is highly required for you to have some knowledge of limits, right? First you have to study this chapter limits and then only study this chapter continuity, right? Because many of the concepts, many concepts of limits are going to be used in this chapter directly or indirectly, right? So it is very much required for you to have a knowledge of limits before starting this chapter, okay? And let us first of all quickly revise, right? Let us have a quick recap of whatever we have studied in limits. Okay, so what is limit? Limit is if LHL is equal to RHL, left hand limit is equal to right hand limit, and which is equal to finite, then we say that limit of a function will exist. Okay, this is a condition for limit to be exist, right? So if there is a function f(x), and if I say that limit of this function exists, then what should be the condition? The condition should be LHL should be equal to RHL should be equal to finite. What is LHL? LHL is nothing but f of a minus, right? If I am talking about at some point x equal to a, if I am finding out the limit of this function at x tending to a, right? X tending to a means I will talk about this function, I will talk about the limit of this function at x equal to a plus, which will be called as right hand limit, and also I will talk about the limit of this function at x equal to a minus, which will be called left hand limit. And if this LHL is equal to RHL is equal to a finite quantity, then we will say that the limit of this function exists, right? So this is what we have studied in this chapter, limit, right? Also, what is f of a? F of a is nothing but the exact value of the function at x equal to a, right? This is x approaching a. So there is a huge difference between approaching a and equal to a, right? If x is equal to a means x is exactly equal to a, not slightly less, not slightly more. But if x is approaching a, that means what? If x is approaching a, that means x is never equal to a. If x is approaching a, that means either x will be slightly greater than a or it will be slightly less than a, but it will never be equal to a. Okay, so there is a difference between x equal to a and x approaching a. So limit is defined for x approaching a, and the value of the function is for a fixed a, right, for a fixed a. So f of a will either be defined or it will not be defined. F of a is nothing but the value of the function, okay, and both of them are completely independent. Why I am saying completely independent? Because whether limit exists, if limit exists, this does not imply that the function will be defined, and vice versa also. If function is defined, this does not imply that the limit will exist, right? Both of them have no correlation between them. If limit exists, then also it is possible that the function may be defined or may not be defined, and if the function is defined, then also it is possible that the limit may exist or may not exist. Okay, so limit is completely defined from this definition, which is LHL is equal to RHL is equal to finite. If this definition is satisfied, then we will say that limit exists, otherwise limit will not exist. Also, we can check for the definition of the function, whether the function is defined or not at x equal to a, okay, by the graph or from the definition of the function, how the function is defined. From there we can check it, okay. Now, what is continuity? Okay, so to understand this, what is continuity, these two terms are very necessary, which is, first is the limit of the function, and the second is the value of the function, right, at a fixed particular point. Okay, now let us understand the definition of continuity, right? What is continuity? So in simple words, if I explain you what is continuity, right, then continuity is, if I am drawing the graph of any function, I do not have to lift the pen. If I do not have to lift my pen, then the function will be continuous, otherwise it will be discontinuous. Like see, for example, in this graph, if I draw the graph of this function, then in this graph I will not have to lift pen, right? So this graph is continuous at x equal to a, right? So this graph is continuous at x equal to a, because I don't have to lift pen at x equal to a. But if I try to draw this graph number 2, let me say, okay, if I am drawing the graph of this function, then at x equal to a, I will have to lift my pen, right, because here and then here. In this case, can you tell me what will be f of a? If this value is suppose 3 and this value is suppose 4, f of c, there is a circle here. Circle means not included. This point is not included, and there is a dot here. Dot means this point is included. Okay, dot means included, circle means not included. So f of a will be nothing but 4. Okay, so in this case, function is well defined. F of a is 4, which is well defined, right, which is finite. And what will be the limit of fx at x tending to a? Limit of fx at x tending to a will not be defined, does not exist. Why does not exist? Because you can see from the graph that LHL and RHL are different, right? What is LHL? LHL is for x equal to a minus, so slightly less than a. If x is slightly less than a, what will be the value of y? That means what will be the value of fx? Fx will be slightly less than 3. Okay, so limit x tending to a minus will give me 3, right? So LHL will be equal to how much? 3. But what will be RHL? RHL means slightly greater than a. So if I take x slightly greater than a, that means x equal to a plus. So if I check out the value of this function, if x is slightly greater than a, then the value of this function will be 4, right? So RHL is 4 and LHL is 3. Both are finite, but both are not equal. LHL is not equal to RHL. So in this case, in case of the second graph, right, the function is defined, but limit is not defined. So this will not be a continuous function, right? A function is continuous function only when LHL is equal to RHL is equal to the value of the function and is equal to finite. If the limit of the function is equal to the value of the function and which is equal to finite, then only we can say that the function will be continuous. Okay, so limit should be equal to the value of the function and both should be equal to finite. It should be a finite quantity. Okay, then we can say that the function will be continuous, otherwise it will not be continuous. Okay, so limit should exist, value of the function also should be defined, and both of them should be equal. These are the 3 conditions that we have to check for checking the continuity of a function. Right, now in third case, you tell me, what is the value of the function first of all? See, here also there is a dot, here also there is a circle, and here also there is a circle. So I can say that f of a is not defined at all. What is the value of y? What is the value of f of a? F of a is not defined, right? Because there is no graph at x equal to a. There is no dot anywhere, right? So f of a is not defined. So function itself is not defined, so it will never not be continuous. And we can see from the basic definition also that we have to lift pen at x equal to a. So function should be discontinuous at x equal to a because we have to lift the pen, right? Or mathematically also we can check it that function is not defined. If function is not defined, then we will say that it is discontinuous. Okay, now take the fourth case. Now here we can see that what will be f of a? F of a is again not defined because again it is circle. F of a is not defined, right? Because at x equal to a I am not getting any value of y. So f of a is not defined, right? Exactly equal to a, right? But what about limit? In this case, limit will exist. Why limit will exist? Because LHL will be equal to RHL. If I suppose this, if I say that this value is 3, suppose. Okay, then what will be the limit? Then the limit of this function will be equal to 3, because LHL will also be 3, because you can see that at x equal to a minus I will get the value 3, and at x equal to a plus also the value will be 3 only. Okay, so limit of this function is exists, but the function is not defined. So this will be a discontinuous function. Okay, again if I check, suppose if I say that this value is 4 and if I say that this value is 3, in this case what is f of a? In this case f of there is a dot here, right? So f of a will be 4. Okay, but what will be the value of the limit? What will be the limit? Limit of fx? Limit of fx will be 3, right? Because LHL and RHL both will be 3. If I check at x equal to a minus or if I check at x equal to a plus, in both the cases I will get limit as x equal to limit of this function will be equal to 3. So function is also defined, limit is also defined, both are defined. See, in this case function is defined, which is equal to 4, which is a finite quantity, very well defined, and limit is also defined, limit exists, right? Limit also exists, function also defined, but both of them are not equal. So again this will be a discontinuous function. Okay, this is also a discontinuous function. Okay, and in this case if I check what is f of a is not defined, right? Because I don't see any value at x equal to a, because it is going on and on, but it will never touch this, right? So f of a is not defined, and what will be limit? Limit also does not exist. Why does not exist? Because it is going up to infinite, right? So limit is not finite, right? It should be a finite quantity also. So in this case I will get infinity, which is does not exist. So limit also does not exist and function is also not defined. Okay, so both are not going in favor of us. Okay, so this will also be a discontinuous function. Okay, so there are two things for checking out the continuity of the function. Either you can check directly from the graph whether you have to lift the pen or not. If you are not lifting the pen, then the function will be continuous. If you are lifting the pen, then the function will be discontinuous. Okay, this is first thing. Second thing is, if you want to mathematically check whether the function is continuous or not, first find out the value of the function at x equal to a, at the point at which you want to check for its continuity or discontinuity, right? So find out the value of the function at x equal to a, right? And the second thing is find out the limit. Okay, and if both of them are equal, if the limit of the function is equal to the value of the function and is equal to finite, then we will say that the function is continuous, otherwise it will not be continuous. Okay, so I hope this slide is clear to you. Now let us go to the next slide. What is the mathematical definition, right? The mathematical definition is the same that I told you just now, which is if the limit of the function is equal to f of a, right? Now limit of the function is equal to f of a, that means limit should be defined first of all, right? Then only limit will be equal to f of a. Now for a limit to be defined, what is the condition? I just now told you in the first slide, right? What is the condition for limit to exist? Limit will exist if LHL is equal to RHL is equal to finite. This is the condition for limit to exist. So limit should exist and also this should be equal to the value of the function, then it will be continuous. So this will be the condition for a function to be continuous. What is the condition for a function to be continuous mathematically? Mathematically we can check by finding out the limit. First find out the limit, find out the value of the function at that particular point, and then check whether both of them are equal or not and both of them are finite or not. Okay, so both should be equal and both should be finite. It should not go up to infinity, right? Because otherwise again it will become discontinuous. Okay, so limit of the function should exist, function should be defined, and both of them should be equal. Then we will say that the function is a continuous function at that particular point only. Okay, so this is the mathematical definition. Now let us talk about continuity in an interval, right? So till now we were talking about continuity at a point. Okay, I repeatedly said fx is continuous at x equal to a, right? But what if I want to check the continuity of a function over an interval a to b, right? So a function is continuous over an interval if it is continuous at each and every point in a to b, right? So suppose if this is the function, this is the graph of a function fx. So this function is continuous in an interval a to b, where b is greater than a, obviously, right? If I am talking about interval a to b, that means b will be greater than a, right? So this function will be continuous in a to b if at each and every point it is continuous. At all these points between a and b, the function should be continuous. Then and only then we can say that fx is continuous in full interval a to b. Okay, Now a function is said to be continuous in a closed interval, right? This was open interval. So we can talk about open interval by this definition, but if we are talking about closed interval a to b, okay, then the function should be continuous in a to b, right? The first condition should be satisfied. Also, if I am talking about closed interval a to b, then the function should be continuous at x equal to a, and the function should be continuous at x equal to b also, right? Because if I want to say that the function is continuous in closed interval a to b, that means x equal to a and x equal to b are also included, the endpoints are also included, right? So at x equal to a and at x equal to b, the function should be continuous at the endpoints, right? Basically, so function should be continuous at the endpoints also, right? It should be continuous in between, right? In between all these points, right? Between a and b, whatever the number of points, there the function should be continuous. Along with that, it should be continuous at x equal to a also, and it should be continuous at x equal to b also, right? Now, how will we check about the continuity at the endpoints, right? If I want to check the continuity at x equal to a, right, now in this case, see, suppose if the graph of the function is defined from here to here only, right? This is x equal to a. Okay, let me draw the graph here. Suppose the graph is like this. This is x equal to a and this is x equal to b. Okay, so graph starts from here and it goes like this and it ends here, right? So fx is not defined for x equal to b plus. If x is greater than b, then fx is not defined. Okay, it is defined only in this interval a to b, right? Anywhere else it is not defined. If x is less than a, then also fx is not defined. If I want to check the continuity of this type of functions, right, at the endpoints, that means at x equal to a and x equal to b, then what I will do is, in this case, see, for x less than a, the function is not defined. So in this case, if I want to check the continuity, then I will only check for x equal to a plus, right? So if the limit of the function, so this is nothing but RHL. So if the RHL is equal to f of a, RHL means right hand limit is equal to the value of the function at that particular point, then, and which is equal to finite also, right? Then the function will be right continuous. It will be right continuous means it will be continuous from the right side. Okay, and here it should be function is left continuous, right? It should be left continuous, right? F is left continuous at b if the left hand limit, this is nothing but LHL, if LHL is equal to the value of the function which is equal to finite, right? So here, see, for x equal to x greater than b, the function is not defined. If x is greater than b, then the function is not defined. Okay, so if I want to talk about the continuity at x equal to b, then I will have to check with the LHL, right? Because only the left hand side is defined. So we can check about the limit at b minus only. For b plus it is not defined, right? So we can check for LHL, and if this LHL is equal to the value of the function at that particular point, which is x equal to b, then it will be left continuous, right? So for checking the continuity in an open interval, you have to consider only one thing, that is in between whatever the number of points are there, right? Between all the points in a and b, it should be continuous. And if you want to check in a closed interval a to b, then whatever points are there between a and b, there it should be continuous, plus it should be right continuous also, and it should be left continuous also. That means it should be continuous, the function should be continuous at the endpoints also, that is x equal to a and x equal to b also, right? So this is the continuity in an interval. Now let us solve some questions, right? Because if we solve some questions, then only our concepts will be clear. Okay, so let us solve the first question. Find the points of discontinuity of this function. Okay, so a function is given fx and you have to find the points of discontinuity, right? Now generally the functions are discontinuous at the critical points only. Now what do you mean by critical points? Critical points means those points where denominator goes 0, right? Or whether the function of the critical points, the basic definition of critical points is where the definition of the function changes. Definition of the function changes means definition of the function changes. Okay, so the value of the function was something else for x greater than a, and the value of the function is something else for x less than a. That means the value of the function is changing, right? Then that type of points are called critical points, right? So critical points are the points where the definition of the function changes. Okay, and generally how to find out critical points? By putting denominator equal to 0, right? So wherever denominator becomes equal to 0, there we will find the critical points, right? There the definition of the function will be changed, right? So if I put this denominator equal to 0, basically I will get what? X minus 1 equal to 0. So I will get x equal to 1.
So my critical point is x equal to 1. Now I will have to check, right? Directly I cannot say that this function will be discontinuous at x equal to 1. Right? First find out the critical point. First step is find out the critical point and then check at the critical point whether the function is continuous or discontinuous. Right? Directly don't comment that functions will be discontinuous at all the critical points. Right? This is not true. So first find out the critical points and then check whether the function is continuous or discontinuous at the critical points. Okay, so our critical point is x equal to 1. Now check whether at x equal to 1 this function is continuous or not. Right? Now what is f of 1? If I find out f of 1, this will be 1 by 1 minus 1, which is 1 by 0, which is not defined. Denominator cannot be 0. Alright, denominator cannot be 0. So this function will not be defined at x equal to 1. If function is not defined, it will be discontinuous. Right? Because what is the definition of continuity? Definition of continuity is limit should exist, function should be defined, and both of them should be equal. Here function itself is not defined. So this is discontinuous at x equal to 1. Right? So find out the points of discontinuity, right? So what is the point of discontinuity for this fx? X equal to 1, right? So this function will be discontinuous at x equal to 1. This is the point of discontinuity. Now let us check for gx equal to mod of x. Now for this mod of x, you might be knowing the graph of mod of x itself. So you can directly plot the graph if you know. It is V-shaped, right? This is the graph of y equal to mod x. Now if you see the graph, you can see that I can plot this graph without lifting the pen. I can easily plot this graph, right, like this, V-shaped. So this is the graph. I can plot this graph without lifting the pen. So this graph is continuous. So gx is continuous for all x, continuous everywhere, because no need to lift the pen, right? So gx will be continuous everywhere for all x element of R. Understood? We don't have to lift the pen. So either you can check it by graph or you can check it by the mathematical definition also. See, if I check it by mathematical definition, what is g of 0? Right, here the critical point will be x equal to 0, right, where mod becomes equal to 0. That will be the critical point, right? Whatever is present inside mod, what is present inside mod? X is present inside mod. So whatever is present inside mod, equate that to 0. That will be the critical point. So in this case, x equal to 0 is the critical point. What is g of 0? Now we will check at the critical point whether the function is continuous or not. So g of 0 is mod of 0, which is nothing but 0. Okay, now check the limit, right? So what will be the limit? LHL? LHL will be nothing but g of, LHL we will write g of, right, not f of, g of 0 minus. Now g of 0 minus will be how much? Mod of 0 minus, which will be again 0, and what will be RHL? RHL will be g of 0 plus, g of 0 plus will also be 0, right? So limit, so LHL is equal to RHL is equal to the value of the function, which is equal to 0. So I can say that this function is continuous at x equal to 0, right? Gx is continuous at x equal to 0 because LHL is equal to RHL is equal to the value of the function is equal to finite, because 0 is a finite number, right? So it is continuous. Okay, let us do another example, right? This is a more interesting example. Now in this case, again, first of all, we have to find out the points of discontinuity. So first thing is, we will find out the critical points. And to find out the critical point, what should I do? Put denominator equal to 0. I will get the critical points. So denominator equal to 0 means this quantity should become 0. Now this quantity equal to 0 at which points? Right, see now, can I write this x square as mod of x square? X square, can I write it as mod of x square, right? Doesn't make any difference because x square is also positive and mod of x square is also positive. There is no question about negative numbers, right? So I can easily replace this x square by mod of x square, and now it will be easy for us to factorize, right? If I factorize, this will be mod of x minus 2 and mod of x minus 1, which is equal to 0. So from here I will basically get either mod of x should be equal to 2 or mod of x should be equal to 1, right? If mod x is equal to 2, what should be x? Mod x is equal to 2, then x can be either plus 2 or minus 2, right? Because mod of minus 2 is also 2 and mod of plus 2 is also 2. And if mod x is equal to 1, what is x? X is either plus 1 or minus 1, plus or minus 1. So if I am opening the mod, it will become plus minus. Okay, mod x equal to 1 means x equal to plus minus 1, and mod x equal to 2 means x equal to plus minus 2. Okay, so this function, okay, it will be discontinuous at which 4 points? this function will be discontinuous, and here the denominator will go 0, right? So this function will be definitely discontinuous. So it will be discontinuous at x equal to -2, -1, +1 and 2. So there are 4 points of discontinuity of this function, right? So first find out critical points and then check, right? How did we check it? Because denominator goes 0, right? So function will not be defined. At all these points, the value of the function will not be f of a if I say, right? Then this f of a will not be defined at all these points, right? Because denominator will go 0 and it will not be defined, okay? Let us see the third example. Here, fx is given, right? And we have to check whether this function is continuous at x equal to 0 or not. Right, now first of all tell me what is the value of the function f of 0. At x equal to 0, clearly the value of the function is e to the power -1 by 2. F of 0 is e to the power -1 by 2. Okay, now we will find out the limit. Right, we have already found out the value of the function. Now find out the limit. So what is the limit? And limit at x equal to 0, because we want to check for the continuity at x equal to 0. Right, so what? Find out limit x tending to 0 and this function. This is cos of cot square. Now if you look carefully and if you have studied limit very carefully, right, this is 1 to the power infinity form. And how to solve 1 to the power infinity form? Okay, for this you will have to revise a little bit concepts about limits, right? So this goes like e to the power limit x tending to 0, right? If this function is fx power gx, then we have gx, which is cot square x, into cos x minus 1. Okay, this is standard way of solving 1 to the power infinity form. Okay, you should revise a little bit about this from limits. So this will be e to the power limit, and how will I solve this? This is cot square is nothing but 1 by 10 square, and this is cos x minus 1. Right, now to solve this, what will I do? I will just simply divide by x square. Multiply by x square and divide by x square. Now what is the limit of this? 10x by x. 10x by x is 1. So limit of this is 1. And what is the limit of this? 1 minus cos x by x square was 1 by 2, if you remember. 1 minus cos x by x square. This was 1 by 2. So cos x minus 1 by x square will be minus 1 by 2. Okay, so this will be, so what will be the limit of this function? This will be 1 into minus 1 by 2. So this is nothing but e to the power minus 1 by 2. Now you can clearly see from here that limit at x tending to 0 fx is equal to the value of the function. So this function will be what? Continuous. So this is a continuous function. Alright, I hope this is clear to you, all of you. Okay. Okay, now let's solve the next example. Now here fx is given, right? The definition of the function changes at x equal to 0. Right, and it is also given that find the value of a and b if fx is continuous, right? Here already in the question it is mentioned that fx is continuous at x equal to 0, right? F is a continuous function at x equal to 0. Now what we have to do here is we have to find out the values of a and b if fx is continuous. So this is a reverse process, right? It is already given in the question that fx is continuous, and now we have to find out the values of a and b. Okay, now first of all tell me what should be condition? What should be the condition is if fx is continuous at x equal to 0. If fx is continuous at x equal to 0, LHL should be equal to RHL should be equal to f of 0, and this should be equal to finite. Now what is the value of f of 0? At x equal to 0, the value of the function is b. So f of 0 is nothing but b. So LHL and RHL should both be equal to b. Right? Now first of all, let me find out what is LHL first. Let us try. Right, so what is LHL? LHL will be for x equal to f of 0 minus, right? I will check at f of 0 minus, so x less than 0. So I will consider this definition where x is less than 0. Okay, now here limit x tending to 0 minus and this function, right? And this is 1 to the power infinity form again. Right, this is 1 to the power infinity form in limit. So again the method for solving this will be e to the power gx into fx minus 1. So basically here you will get limit x tending to 0 minus, and gx is a by mod of sin x into fx minus 1. So this quantity minus 1 means this 1 will get cancelled and into mod of sin x. So basically this mod of sin x will get cancelled and limit, left hand limit will be equal to nothing but e to the power a. Okay, now let me find out what is right hand limit. Right hand limit will be, I will consider this definition of the function where x is greater than 0, right? So f of 0 plus. F of 0 plus means limit x tending to 0 plus and e to the power, what is the function? Tan of 2x divided by tan of 3x. Now if I want to solve this, what will I have to do? I will just multiply, divide by 2x and 3x. So here 3x and here 2x, and the balance will be 2 and 3, right? So I am just multiplying, dividing by, okay, 3x, 2x and then 3 and 2. Okay, now what will be this quantity? Tan 2x by 2x will be 1 and 3x by tan 3x will be 1. Limit of this function because x is tending towards 0. So this limit is 1, this limit is 1. Okay, so basically what will be RHL? RHL will be nothing but e to the power 2 by 3. RHL will be e to the power 2 by 3. Now apply this condition, that is LHL equal to RHL equal to f of 0, which is equal to b. Alright, so e to the power a, this is LHL, this is equal to e to the power 2 by 3 and this is equal to b. Okay, so what will be the value of b? Answer will be, value of b will be e to the power 2 by 3 and value of a will be, from this equation, value of a will be just 2 by 3. So we can find out the values of a and b easily from here.
So students, I hope that continuity of a function is clear to you, the definition is clear to you. I hope you enjoyed watching the first video. Now in our next part, I am going to tell you about the reasons for the discontinuity and also the types of discontinuities. So stay tuned till then.